Welcome to our Python class, and today we will look at object-oriented programming in Python, OOP for short, and the two major concepts, the class in OOP, which means it's basically a blueprint for something, for some idea, for some data and some methods, and objects, which are actual real instance, a realization of this class blueprint. So again, class is like a blueprint, and object is something which uses this blueprint to create something. Okay, so that's very high level view, right? Not language specific. So we'll take a look how Python implements classes and objects. And I should mention that in Python pretty much everything actually is an object underneath. We've been using objects all along, we just didn't know it actually, right? So today we'll learn actually how to create your own classes and objects, but I should mention again, you don't have to use this style. Again, OOP is actually a programming style, right? You don't have to use it all the time, right? But it's helpful to know how it's done, because many libraries, many tools use this paradigm, this concept. But again, you can write in your regular style with just functions alone, but hopefully today you will see that classes, and their realization objects actually have their place. Okay, so again, like I said, classes combine. Again, we're looking at classes.py today. That's a file, day 10, well, technically day 11, right? So they combine related data, properties, and also some functionality, or functions if you want, and they're called methods. And again, so classes are blueprints for this functionality and this data storage, and objects are actual real implementation, right? So concrete objects are concrete realization of these blueprints classes, right? So again, why does this need? Why should we actually have something else, right? We have our data structures, we have our functions. Again, people actually got along pretty well until about 1970s, right? Till these ideas of OOP appeared, right? So, but Python has been built since its start in 1990. Actually, has been built with the idea of OOP underneath. So, but here's the idea. So we want to have some data about garage, right? So we could of course use a list, right? We have paint can, old papers, rotting potatoes, something like that. We could also use a dictionary, right? We could store some paints as a list, right, and food, potatoes, and that's okay. And we could also, actually store some functions underneath in our dictionary. It is possible, actually, right? However, still, it's not. If you want to do some, perform some movement with these data, it would be nice if those methods would be close, those functions would be close together, they would be grouped together. Well, so OOP lets us combine these values, properties, and these functions in a single entity. But let's start with something really simple, an empty class, right? And I'm gonna call it, so notice I'm using a reserved word class. Again, you can't have a variable as a class, this is a special word, an empty class, and colon, again, just like function definitions, like we use if and loops, right? And here I am using a pass, so this is a completely empty definition, right? And okay, will anything happen? Well, let's take a look. Nothing happened. Only thing is I have outline. If I scroll, if I go here, I have my empty outline. So nothing actually happened, except I made a sort of a definition. So I can make an actual instance using this blueprint, which is completely blank actually here, right? I could do something like this and create my first class, right? And this is actually, well, possible, right? Again, so class main empty class. So actually I do have the type. I have created my own data type basically, right? My own class, and I have my own instance, right? My own blueprint. Except the only problem is it's kind of, empty, right? So turns out I can use this empty blueprint and assign some values. For example, I can say paint and papers, right? I can assign some properties, right? Using something called dot notation. Again, this dot notation did not exist. I could say empty class, right? And dot and my, name or owner, right? It will be Valdis, right? Again, completely out of the blue, right? It's kind of nice, this not notation, but of course this is not how you usually use classes, right? But again, so you can store some data, just just bind it together, right, in this instance. So of course if I want to print the paint, right, I would be able to print it, right, and I have red, blue, right, and again, I can assign my values, right, so I can store some data in this object, right. So, but again, it's not really utilizing the full power of class because it's an empty class, right? So again, I could do it, right? And again, notice, right? So if I do another empty class, right, like this, I use this blueprint, which is empty, and I create another empty object, right? Empty object, right? And I can assign completely different values. And again, well, it's really kind of, you see, I have a red, blue here, right? And I have gouache here, right? For the paint, right? And I also have it's one object with its property, and I have another one. The paints are completely different. I use the same blueprint, but it is completely undefined, right? It's just completely empty, so it was not really that useful, right? So this is not how we usually want to use a class. I mean, I'm just showing you you can do it like just for storing some data, right? Ad hoc, so to say, just out of the blue. But usually we will want to use this blueprint. We will want to have some values in this. We want to pre-populate the blueprint with some idea. Maybe some data, maybe some functions, which we'll call methods, right? So for now, I have an empty class again. Let's make a house. So I'm going to make a house, class house, right? Again, I'll have a lot of stuff to say here, right? But for now, right, I have all this good stuff here. I'll do maybe a class property here, right? Class property. So what will happen here, right, is I'll make a new instance. So I'll make a new house here, right? I'll make a new house, right? Again, if I okay, first let me run it. Right, nothing happened. I have a empty class and I have a house with a single property, right? Again, these are class definitions, so they are blueprints, right? So I don't use them directly. I create a instance. So I have a new house out of these blueprints, right? And I can do, well, I can print right now, print print new house, right? And notice something now. I do dot, right? I should see, well, if it picks up new house, all house dot all, yeah, all house property. Actually, it should be quicker, right? It's all house property because color is not yet defined. If I do color, it will be a mistake. But all house property, right? Just my name I came up, right? I will come up with a brick. You see, I have brick. So the good news is, so all blueprints, all objects created from these house blueprints will have this property set. So I have another house, right? Notice, right? And also I can print this property. So they're completely unrelated object. I mean, they have the same, they started their life using the same blueprint, but they have their own lives now. So I have another house, right? And I can print again all house property. And notice again how if I go back, I see here, right? I use this dot, right? Come on, right? Of course, it's saying here, but if I do this, it tells you, right? All, well, now I have my Copilot fighting with Visual Studio Code, right? It already knows about this property. But yes, so most good editors, again, one of the reasons why to use this class-based design is that you have this assistance, right? Okay, you start with this object basically, right? And you have these properties, right? Just for now we only have a single property and we can print it. So brick. Okay, and we can actually change these properties, right? So, but that would not be all. So you could store it. We could store some more data like this again, but that's not all. Classes usually also define some methods. So basically the idea is we have some data and we also are going to store the methods, the functions, which are going to operate on this data in the same place. Again, it's for mostly, again, for organizational reasons. It's a way of designing larger programs, which makes, handling, very, very complex, assignments, projects, much easier, right? Okay, so let's do that, and let's add a simple or first method. So this is going to be a very simple method, but there's a slight catch. So notice something here. So I have defined a print house property, right? So this is called method definition. Again, what is a method? Method is simply a function which is defined inside the house, right? I mean inside the class, right? You know, it doesn't have to be house, it could be any class, right? So that's called method, right? So notice again the indentation, right? It's inside the class declaration. So it's a blueprint. So it's okay. It says, okay, you want to do something, here are instructions, right? So only strange thing will be this self, right? And this is extremely common in class object-oriented programming. Actually, in many other languages use something called this, but Python uses self for some historical reasons, because it was inspired by different language. So idea is this is a reference to itself, right? To its own property, right? For the object, right? So this self in Python, you have to always, if you do a class, you do a method, 99% of time you will want to write self, right? Actually, it will not run otherwise, right? So you need to say self. Again, technically this could be something else. You could call it something else. You call it this or something else. But by convention, 99.999% of time you call it self, right? And again, so this is going to let you access anything else within this house, basically. So let's see how it works. So now I can do this, right? Another house, right? So now, right, I can use a method. So notice something very strange is that I don't call self. So self does not have to be specified, right? I mean, we wrote it here, right? We're going to keep writing self, but it does not have to be you. So it's automatic. So basically, Python saves you some typing, and self is actually implied. So if you call a method which is part of this object, right, it will be implied and will run self. So again, notice again this dot notation. So we've been using this already. Remember, our list methods or dictionary methods or set methods, they use the same approach actually, right? They use the same approach. So yeah, so see brick, right? So just to show you, I can also change my brick house to a straw house, right? And of course, it's again, they have completely, again, these are two completely, they started the same blueprint, but now they have their own, they live their own lives, right? Of course, I could keep adding some more, data inside, right? So let's see what else can we add before I move to a more complex example, right? So yes, so one of those things which make it a very, so to say, which makes class design powerful is something called constructors. So idea is this, that when we start our house or our class, right, we make our instance, we call special function. So it's the initialization function or construction function, which will set up things, right? So otherwise, here I have to set up more things, right? I have to keep adding more things by hand. Well, wouldn't it be nice if I could have some default properties set up ahead of time? So that's the purpose of special class method, and it's called init in Python, double under init, and it will set up, let you initialize the house. So basically, this is where you write whatever you want done when you make a new object using this blueprint. So, right, so we add everything we want done when we first create object from our class blueprint. So this is a very important concept again. So generally classes will have a constructor function, right? So for now, I'm gonna, here I'll do self color is color, so something like this, right? So what I do is here, I do self color is color, self color nails is nails, right? So basically, I am passing a color green by default and number of nails 0, right? And now I'll have three properties. I have this sort of this outside property, and I also have two more properties. Again, when I say properties, think of them as variables, right? In Python, right? They are basically sort of glued to this. The blueprint sets the instructions, and when you make an object, they will be sort of like attached together, right? So self color, self nails, and self all house properties, right? So let's take a look how it will what will happen now. So I added this new method, this double under method, and let's take a look what happens. You see, this house is built from brick, this house is built from straw, this house is built from brick again. So I have three houses actually, right? So this constructor was actually no, here. Actually, I only have two houses. Sorry, I have only two houses, right? I have this was from more calling these properties. So again, this whenever I create this house, right? New house object, this constructor was called. So let's add one more, right? I'll make my new house, right? And notice, right? It will have already house color and house nails, right? Right? You see, green. So I made another third house, same blueprint, but again it initialized. So I have my house color, right? And again I could also, so green, nails, and brick. Again, I could change to clay, for example, right? I could change anything, but let's do a build house. What does build house implies? Let's see. Build house is another method, right? It just tells you, does nothing extra special. It just says what to do, right? It builds a house, right? It prints something, right? And well, only strange thing, it returns self. We'll talk about that in a moment. So builds a house, prints some properties. It does something, right? Again. And so let's do that, right? So building a house of brick, right? Okay, so brick is from here, right? But this is building a house of brick. Its color will be green. It's okay. I need to. That's a bad English, right? Not good English. Where is my function? Its color, right? Very common mistake, right? I don't know how I made it, but it happens, right? Its color will be green, right? So again, I can make some more methods again. So only thing I'll show again. So this, of course, so far we're not doing anything fancy. Oh, color nails, right? Simple print. Let's take a look, right? And let's make a summer house again. So what will be different? So I have four objects. Well, again, I have the same blueprint, but four completely different objects. Okay, so initialize the class instance with self color green, but I have 500 nails, right? Right. So I can build a house, my summer house. I can print it, right? And again, building house green. Again, notice how I can see here everything that has to do with my house blueprints. I can check the property, right? Print house property, the method, initialization method. There it is, new house, and I have some objects. I can walk around. I mean, with these objects and see how the blueprint was implemented, right? Build house. So I have how many functions do I have? Again, I say functions. I mean methods in this case, right? So 1, 2, and 3, 4 methods. And how many properties I have? I have one general one outside of the initialization, but also I have them here, right? Question is usually, do you need them here or here? Well, actually, it's better to leave them outside. Don't actually use any here. Actually, initialize everything, right? That's better. And again, I like this approach of doing some defaults, right? So you can start with some sane defaults, right? So idea being you start with some sane of defaults. So good practice to have sane default values, right? So then you can call it the initial. You don't have to do anything. You have an empty call like this house, you know, and all the nails and color green, assuming you want all your houses green by default, will work. Okay, right. And again, if I need to, I can make a red house, right? I'll call it red house, right? Right. Again, notice how self is not mentioned, right? even init has to have the self, right? Because again, we use it whenever we need to refer to or this object, related to this concrete object, right? So self will be referring to specific object we create, right? So it's like internal reference, basically. It's like an internal reference. So red house color, right? Color red. Again, it's just like, again, we have a blueprint and we created a bunch of houses. Maybe I'll have this one here, right? So I have a car class, and again it has some properties, and again also has some methods. Again, a very, very common analogy. Okay, let's see how are we doing this time. We're doing pretty good. Let's continue. Maybe we'll make a friend's house, right? Again, of course I can do this here, right? Friend's house, house color, nails 1000 on. Right, and again, so I made a self color blue, self nails, self all house, right? Maybe owner, maybe we should set, okay, so we decide owner, right? Let's say we want to have an owner, we could, right? So let's add an owner, right? We don't have it yet, so we could do it here, right? In the constructor, owner will be maybe empty string, right? Why not, right? So again, by itself this will do nothing, but if I do it here, right, I'll add it here. So self owner will be owner, right? So a way of setting up, right? And now of course I can add it here, right? I can add it here, self owner, right? So I will see who the owner is. And again, notice I added this new property, but my code will not break because I use the default value. My code will still run, right? Because nothing else changed. The only thing that changes is that the owner is unknown. So let's make an owner, let's add an owner, right? I can always add a house, my house, right? I'll do this, owner Valdis, right? Why not? Owner Valdis, again, so, again, I can skip the rest. I have 0 nails and I don't like green color. Well, actually I like green color. Okay, sure, I'll stick with green color, right? My house, on. See, let's check where's Valdis. These have no owners, but here there should be an owner Valdis somewhere. Where is Valdis? My house. Oh, I don't see it here. It should be somewhere here. Can you find it? Where is Valdis? Brick owner. Maybe I didn't do it correctly. Let's take my house. My house color, my house properties, my summer house. Let's see, owner is Valdis. Did I really make a mistake or not? Maybe I didn't do something correctly. Let's check. Look, self owner is owner. Looks okay. Maybe here? No. Looks okay. Let's see. I can't find myself. Okay, let's do this. Let's add the last one. What's the last house? Nails, owner. Let's say Edgar's, right? Owner is Edgar's. Let's see. Oh, Edgar's is here. Maybe I'm missing myself somewhere. So Edgar's is here. It works, right? But where's Valdis? Well, probably we need to scroll up a little bit. Maybe close this. Right, Edgar's is there. Maybe I have typo somewhere. I don't see. Here's Valdis. Okay, yeah. Valdis also is an owner here. All right. So the classes provide the blueprints, the idea of how we're going to store our data, and how we are going to store some methods. Let me add a few more methods we have not yet implemented. Let me add a set color method. It's so-called the setter method. So-called setter, right? So-called setter method, right? There it is actually, right? Already. So why would you want to do something like that? So it's a control. So idea is to control how we set the value, right? Again, if you can insist that, well, you should only use this set color method to change color. Well, with Python, actually, it is Python is extremely liberal. Like I told you, it will let you change it anyways, right? It won't protect you from changing it directly. But this is sort of provides an idea of how to adjust values. Let's see, and I think that's it. We still have a class method, but let's see here, and let's implement this, right? Well, we can run the code, right? And everything works fine. Blue, color blue. So now we'll do something really strange. Notice this self, right? So whenever in the class methods, when we define our methods, we have nothing good to return, it's a good idea to return self. What does it do? What's the idea? Well, it will let us chain. So by returning self, we can keep chaining because we are returning ourselves, right? It's a pretty powerful idea used by many libraries, for example, Pandas, among others, is that we can chain our properties. Let's check something like this. So friend's house, right? Dot. Well, we can build a house, right? Then we can set color yellow, and we can see, well, we can build a house again. So why does this work? Again, it works because, and then we can do simple print, right? Okay, so we can, so notice how this method returns a house, and in this case it returns the same house, right? So you'll see that it could return a different house, but in this case it returns itself. So this means we have a house, we have an object of type house here. When we build it, we call a method, we'll have it again. So we can keep chaining. So this makes a pretty powerful way. Again, what's the big idea behind this? It's if you somebody else makes this class blueprint, maybe not yourself, maybe you did it yourself 6 months ago, and you don't have to do much deep code inspection to start using this, right? You just make a object, and then you have access using this dot notation. You'll have access to these methods, and you can basically start using it without actually knowing the internals. It's a way of encapsulating the sort of modularity. You sort of hide the complexity again. It's another way of hiding complexity, right? So simple print, and we'll have it. It'll run. So basically, we could have done all this by single, same as build house, right? So same thing, right? Same thing, but just in one line. Same thing, just in one line. Okay, right? So again, same thing. Again, if we did not have self, we would have to do this like by one, right? Okay, I think that's a good enough start for the first starting with classes. We'll get to more complex. Well, we'll start building a garage next, but well, I have a few more minutes. People have asked me, this is a little bit more advanced topic, is how about methods which don't need can you have a class method, meaning a method which is not part of the which doesn't need an object. Basically, here, right, we have a blueprint, and we just keep producing objects, right? I have my house blueprint, right? And I make new houses. Well, sometimes you want to store some methods which don't, each object gets its own methods. So these functions, these methods are assigned to each object. But sometimes you want to have it separate, right? You want some utility function, right? Sometimes you have some utility function. Then you use a special decorator, right? And you could do this. So this is something. This is gonna be this class method which will. Yeah, so single copy. So we can use without. So main thing is we can use it without creating any objects, right? So that's kind of interesting. So notice let me first now let me finish. I won't build anything. I'll just stop building any houses. I'm gonna comment everything, right? Yeah, no houses, right? Let's run it. Nothing, right? I just have my house definition. I have my empty house, right? But notice, even without any objects, I can use now this special class method, right? It has CLS, right? It also has access to this brick, by the way, right? We can use it directly, something like this, without any methods. So I don't have any houses, but I can already start using this house add utility function, right? On 5, 11, 16 brick, right? So it has access to this. So you can actually use it sort of like again to group things together without actually making any objects, right? But again, this is much less. You probably don't want to use. I mean, it's maybe less used, right? But again, it's a possibility, right? If you want to use it, just use your house, your blueprint. So these are called class methods, right? Not general methods, but actually class methods, right? So you can use it before you make a house, right? But of course, again, if I make a house, right? Of course, it will work also afterwards, right? So yeah, all right. So hopefully you got an idea. Main concepts to remember: blueprint, right? Generally, usually we will have a special function. You don't have a choice here. You have to call it two underscores, double under in it, and two more double underscores, right? Again, all methods we use self, right? Which is by default, which is included. And again, usually it's a good idea to include the default values, but you don't have to. Like here, set color doesn't have a default setter. You basically means you have to always have at least one parameter here, right? So big idea is to use classes to define some properties, some data, and methods which will operate on this data. All right. Thank you everyone, and we will tackle more deeper house issues in the next lecture.